this is a little gadget I built that can count pulses. I'm going to show you what it does, and then I'm going to show you how I built it. So a friend of mine gave me this kit, 37 sensors kit. It's got all these different sensors for Arduinos and microcontrollers. There's loads of different sensors that you can get that can generate pulses. For example, this one here is called a Hall effect sensor, and it detects a magnet going past it. So a magnetic field going past it. Right, so let's try it out. Let's plug this Hall effect sensor in. This Hall effect sensor, it's on a board, but all it is, let me zoom in right into this. All it is this thing with 3 pins. This board doesn't do anything. It's literally just it just literally connects it to these 3 pins. It's just a breakout board. There's no other components on that. Okay, so let's plug this in. Okay, now in theory, if we move a magnet close to this, I've got a tiny little magnet here. Let's stick this on the end of a stick. So if I bring a magnet close to this, it should get a... See, it measures, counts 1. So every time I go near it, the bottom one's counting. Don't know if you can, I don't know how well you can see this, but like, it's got like RPM and total. Total means like the total pulses that it's detected. Let's try something slightly different. So these cigarette papers, they've got a little magnet inside there to like keep them shut like that. Let's try making a little sort of wheel thing out of this. It's just a proof of concept. This doesn't have to be fancy. Not that anything I do is. Okay, that's not very round at all. Let's find something to stick in the middle of that. That will do. Right, so we can spin that. Let's get something to spin it. Let's go for this. Right, so okay, so let's find out if this can detect how fast that's spinning. No, interesting. Wait, what if I go on the other side of it? It's not picking it up at all. Huh. Wonder if it's because the magnetic field's not strong enough. Stick these other magnets on it as well. Okay, that's like 3 little magnets stuck together now. No. Tell you what I'm wondering. Let's take this off. Let's put this screw in the other. Hang on. Actually, let's just do this manually and see if we can get anything to register. Ah, yeah. So this is an interesting thing about these Hall effect sensors. Check this out. See, I was just spinning it with that on this side of the magnet. Look, and that's not detecting anything. See, that total number's not going up. But if I do it on the other side of this thing, so on the back side of this thing, then it goes up. 16. Let's do this. Let's stick these on this side, and then let's. Like magnets obviously have a north and south pole, and the Hall effect sensor only activates on one side of it, basically. I can't even tell you which without looking it up. I guess I will flash it on the screen. But yeah, so now that I've turned this round, now this should... Yeah. Okay, so this should work a bit better now. That's pretty cool. Yeah, so that's the concept of how this works. That magnet goes past there, and the thing does the thing, counts the thing. There's loads of different sensors that can generate pulses. This one's called an avoidance sensor, which kind of detects things coming close to it. It bounces, I think it's ultraviolet light, out of that one and detects it in that one. So when something comes close to it, it picks up on the on that and generates a pulse in a similar way. You could do something like that. This one is called, I think this is called a photo interrupter, which is, you get different ones of these, but like every time something goes in the middle of that, every time something breaks that, it generates a pulse. So yeah, you could have some sort of wheel turning that broke that. Another idea that this is a little laser thing, and you could have like a laser into an LED, which like an LED makes light, but if you shine light into it, it will actually make a pulse. So you could shine a laser into an LED, and then when you break the stream, it will make a detectable pulse. So yeah, a bunch of different things you could do. Yeah, I noticed when I was like messing with all these different sensors that they're all powered by 5 volts, and they all just have like a third pin that actually carries the signal, that actually like does the pulse bit. So, which is what made me think about making this kind of like generic thing that can read any of them. And then I also put these 2 little pins down here that you can connect an oscilloscope to, so you can actually like see the pulse. You can actually kind of see what's going on. Okay, well what I'm going to do is I'm going to show you how I made this thing, and then after that I'm going to show you how you can use this to monitor the speed of a 12 volt computer fan. Right, so I built this using an ESP32 and an OLED screen, and I built it on Vero board, which is this really cool stuff which I've only recently discovered for prototyping, which has these copper strips that run across it. Just makes for a cool way of prototyping stuff. You don't need as many wires, and yeah, it's cool stuff. Been having fun with that. There is this software I found called DIY Layout Creator, which is pretty cool for prototyping this kind of stuff. It's got different boards, like Vero board is kind of, there's a template for that, and it's quite cool for laying out stuff. I didn't use it for this. It's cool for more intricate stuff, but for this I didn't actually bother. I just kind of freestyled it. Hang on, right back to here. So yeah, this was quite a simple design, so I just kind of freestyled it on the Vero board. So yeah, these are the connections. This ground pin has to be joined to this ground pin on here. So it's something like that. The VCC pin here is connected to the 5 volt pin, which is right down here. Something like that. This OLED runs on the I2C interface, so you have a clock and a data pin. I used 22 for the clock. So something like that. And I used 21 for the data source. So something vaguely like that is how I connected it up. And then these 3 wires coming off, which are for connecting to the different sensors. The brown one is connected to earth. The red one is connected to the 5 volt supply. And the last one, I chose pin 13 for that. Where is 13? Over here. I think it's there. So that's basically the connections of the thing. Right, so to build it, I just cut out the right size piece of Vero board to fit the ESP and the OLED screen on it, and then just figured out where the connections need to be, and just drew pencil lines on the Vero board to sort of plan it out. It's pretty easy to do. Nice thing about the Vero board is you only need wires that go one direction. You don't need wires that are sort of crossing over each other. You're then just tacking them on with bits of solder. Then to make sure the opposite sides of the ESP aren't connected to each other via the copper tracks, I go through with a sharp drill bit, basically a brand new drill bit, and just twist it by hand to make a gap in the copper. It's pretty easy to do. Just have to make sure you get all the way through it. And then here I'm just going through and testing to make sure that those breaks in the copper track actually worked, and then just testing that none of that I haven't bridged any two tracks together by a sort of wayward bit of solder. Just making sure that the things that are meant to be connected to each other are connected to each other. Just going through and testing it all really. I've soldered the board, the ESP and the OLED screen directly onto the board. I just did that because I wanted them to be quite flat profile. I could have used sort of spacer things so I could easily take the board on and off, but I just decided to do it like that. Yeah, and then lastly, just soldering all the bits, including the 3 wires for the connections to whatever sensor I'm using. All pretty easy stuff really. Right, so now that we've built the thing, we need to flash a program on so that ESP knows how to handle the pulses and how to display them on the screen. I've chosen to use ESPHome for this, which is a really cool project. I find it much more straightforward than programming stuff in the Arduino software. You basically do everything via these configuration files called YAML files. ESPHome supports all kinds of different things, sensors, screens, all kinds of different things, which are all kind of listed on their page. We've obviously got an OLED screen, so you just look up OLED. We've got one of these, and then it will tell you, it will just give you the basic configuration to get you started. You know, you pick your screen on there, and then you just paste that into your configuration file, and then you'll have a screen that works. So I started by copying that, and then for the pulse meter, there's actually a built-in where is it, pulse counter sensor. So you define a new sensor called pulse counter, and it just gives you a bunch of stuff for free. It's worth reading about these configuration variables and what they mean. For example, this count mode stuff. This is, say the sensor's normally at ground level, and then sometimes it spikes, and you want to count it every time it spikes, then that would be, you're counting the rising edge. So by default that's set to increment. In other words, every time there's a rising edge, you want to add 1 to the count. but in some situations it might be falling edge. For example, we were talking about earlier, you might have a laser beam which is always giving some sort of voltage, and then when the beam is cut, that voltage drops to 0 volts. Then you might want to count on the falling edge. So in which case you'd need to change these variables. So you'd have the rising edge set to disabled, and you'd have the falling edge set to increment. So yeah, it's well worth reading about these different options. There's this filter here which gets rid of noise if there's tiny little pulses that are less than 13 nanoseconds. Then if there's like noise, then it's not gonna count that as pulses. This update interval, if you want the screen updating every second, then you'd need to set this to 1 second. At the moment it's only going to change the detection every 60 seconds, which is, in most cases, you're going to want it less than that. So yeah, and then this has different filters and all kinds of options. I'm not going to go into all the options here, but basically I cut and paste from the ESPHome website into VS Code. Let me show you that. Setting up ESPHome is outside of the scope of what I'm trying to do in this video, but this is the basic steps. If you want them, you need a Python 3.9 or higher environment, set up a virtual environment, activate it, install that stuff. And then once you've got it set up, you activate your environment. Okay, now I've got an active environment here. And then you set up a YAML file. You can call it whatever you want. I've called it tachometer, but you could call it pulse counter. What kind of board you're using. I've got my Wi-Fi secret and password in a different file. If you give the ESP the credentials of your home Wi-Fi, then you can actually access it and flash it over Wi-Fi, which is really cool. Here I've set the pins that I want for the I2C, which is the protocol that it's using to communicate with the screen, with the OLED screen. I've set the frequency higher than usual because the screen wasn't updating as much as I wanted it to. And then I've set the sensor here, told it what pin I want to use. So I've set the pin that's counting the pulses to 13. Inverted true means that we want to count every time the pin is pulled to ground. What actually happens with the Hall effect sensor is that every time the magnetic field goes near it, the pin is pulled to ground. So by default, what we want here, this mode bit, we tell it that we want this pin 13 to be an input pin, and then we want to use the ESP's pull-up resistor, which means by default this pin 13 is going to be what's called a floating pin. But when we put this pull-up resistor, this pull-up setting to true, by default that pin will be pulled to 3.3 volts. So by default that will be high. I didn't even really have to include this, but I just wanted to have the different options in the configuration file. These are the defaults anyway. When there's a rising edge, it increments the pulse, and when there's a falling edge, it doesn't do anything. This is also set to the default. for the filter I'm doing multiply by 0.5. The reason I'm doing that is when we use this sensor to measure a 12 volt fan shortly, that actually has 2 Hall effect sensors in it. So every 1 rotation of the fan, it will have 2 pulses. So I'm timesing it by 0.5 to take account of that. And then we've also, this total is for the total display. Here we're telling it what font we want to use for the display. You've actually got to find a font, a TTF file, and save that into the same folder as your ESPHome in order to use that. And then this is the settings for the OLED screen. Again, just pasted in from the ESPHome website. Okay, so once you've set that up, all you have to do is connect your ESP to the computer with a USB cable, and then we just type ESPHome run, and then the name of the YAML file, the name of your configuration file. That will then generate the source code, and then it asks me if I want to use, like, how I want to flash it, and I want to flash it with option 1 here, which is over the USB connection. So it's now connected to the ESP. It's right into the ESP. You can see a little red light flashing. And that's done. That's flashed to the ESP. The other clever thing about this, you saw that there's 2 options for flashing the ESP. One was through the USB and one was over Wi-Fi. Once you've done it the first time, if you want to then change the program, then you can actually flash it straight over the Wi-Fi. You don't even need the USB cable anymore. So that's that. I hope that was clear-ish. I don't want to turn this into a full ESPHome tutorial, but yeah, I find ESPHome pretty easy to work with. The other thing is, if you get stuck working with it, ask ChatGPT for help. It can give you all kinds of advice and write your YAML files for you. Yeah, so that's that. Right, so this is a very standard 12 volt computer fan. Done lots of stuff on the channel with these before. Let's give it some power. I'm going to use the bench power supply for this. So we're going red, and black. Okay. Alright, a little bit blurry, but I've got a webcam set up on my bench power supply. So, and I've got this, the power supply going to the red and black here. So obviously, if we turn the voltage up, once it gets to, what, about 3.6 volts, that starts, the fan starts spinning. And the faster more voltage we give it, the faster it spins. So that's that bit of it set up. And as I said, this fan has got 2 little Hall effect sensors in it. So in the same way we set up this Hall effect sensor. Okay, I've got this set up. The 3rd pin on here the white pin on here, which is going to give a pulse every time the Hall effect sensor goes past here. That's going to the orange pin, which is the pin on here that reads the pulse. The ground is showing a common ground, and the red and black from here is going to the power supply. So let's plug that in. Okay. Now I'm going to turn the voltage up on the power supply. Right. At 3.6 volts, it's showing that we're doing nearly 1000 RPM. 1000 RPM. So this is shown at 5.8 volts. We're doing 2000 RPM. It's drawing 172 milliamps. So that's 1 watt. 1 watt of power. Let's go up to 12 volts, up to maximum speed, and see how fast the fan goes. So at 12 volts, it's using about almost 5 watts, and it's spinning about 4000 RPM. So that's pretty cool. And then the other thing we can do, of course, is, as I said, I've got these 2 pins here which we can connect an oscilloscope to, so we can actually see the pulses that the Hall effect sensor is making. And I've got an oscilloscope here, and I've got no idea how I'm going to get this in screen as well, but let's try. Let's zoom out a bit. Oscilloscope probes. I think it doesn't matter which way around these are. I'm not sure. I guess it probably doesn't, but okay, connect those probes to there. There we go. Yeah, look, nice. It's given a nice square wave. Yeah, so if we turn it up, we should be able to see on the Hall effect sensor. They'll get closer together because they're going faster and faster. So yeah, I thought I'd show you guys that because I thought it was pretty cool. I don't know if I've explained any of it particularly well. If you have any comments or whatever, or want to tell me I'm an idiot, feel free to do so in the comments. Cool, yeah. Till next time, peace.